So the choice of this shape normal distribution is based on an assumption. Now, in 2023, if you go and look at any textbook, undergraduate textbook, they will list a bunch of assumptions for a hypothesis test. The first test that we will do is a start with normal test for me. The assumptions for a z-test and z-test, it is for mean. You're testing for the mean. In my example, we tested for the average gas prices. Also, sigma is known. Sigma is the standard deviation of the sample. Under those circumstances, and these assumptions, observations are independent and randomly chosen from one population. When we say random, oftentimes they become independent. Yesterday's seminar, there was a good example the speaker mentioned. I believe it was Cambodia. That was the reference.
Colombia.
Colombia. Oh, you paid attention. Jeez, I better sleep. Colombia, and she mentioned why did the estimation not work really well for Colombia?
Data was from the whole country.
Okay, getting that Omar data is from the whole country. So what's the other country did really well?
It's different population.
It's input.
It's like regional data.
Regional data. So when they looked at Colombia, they simply didn't look at one specific region. They looked at multiple regions within Colombia, unlike the other countries, where they were identical across the country. So the second condition is observations come from an identical distribution, and that distribution, in our case, should be normal. That is our assumption. You might have heard the phrase lies, downlies, and then statistics. Well, if you don't do it right, you're actually lying to people. You have to satisfy these assumptions to make an inference. And you may say, well, how do things work in practice in research? Well, that's why we have peer review. That's why most people look at things before we come to a conclusion. And not only that, there are ethical principles. Good so far. If these assumptions are satisfied, I can assume that they'll get. And still, in my example, I showed the histogram and then I picked a mean for it. That would be your reference mean. What value did we use last time? 6.8.
Yes. 6.5.
Huh?
It's not 6.5, the one that Jason has.
6.5. 6.50. That is my reference time. Under these assumptions, if I want to come up with a null distribution, I should not have a numerical value. Well, I should say numerical value, a specific mean associated with it, because you can't compare something using an assumption that you already made in terms of the average you are trying to compare. So what we do instead, for the test to work, we come up with a distribution that's centered at 0. Not only that, the standard deviation is 1. You may ask, well, why do we want the standard deviation to be 1? Why can't I let it vary? Well, if you let the standard deviation to vary, you could assume something like that, yes, centered at 0, or you can assume something like that, which is, yes, this assumption is going to change your conclusion. So standard deviation should play no part whatsoever in that null distribution. Now that I mentioned that bit, did we use a standard deviation for Jason's assumption last time? I don't think so.
Sometimes on R, change the standard deviation, like one time maybe. But usually you change the mean.
Let's just assume this to be 0.5. Good. So that was Jason's assumption for null distribution, but I want this to be independent of that 6.50 in the sense I want to make it 0. I don't want a specific value of 0.5. I want it to be 1. How would I do this? Give you a hint. X assumption is normally distributed with mean 0 and standard deviation. Sorry, 6.50 standard deviation 0.5. Somehow, magically, I want the mean to become 0, standard deviation to become 1, without changing the shape. Or we have to convert it to a z-score. Do we remember?
Yeah, so x minus v is our standard deviation.
X minus mu divided by sigma. I use mu and sigma because these are population values that I assume something with mu and sigma. When we get to the sample, it will be x bar and s, or you put a hat, mu hat, sigma hat. If I convert this assumption that I've made using that transformation to a bunch of z-scores, I'm no artist, but this shape and that shape are one and the same. More or less. When you put it in that formula, the mean would be 0. The standard deviation will be 1. So what I have to assume is this distribution, which is the null distribution. Good. And this null distribution will work for that test. And the next one teaches as well. Good so far? Yes.
Wait, how come the mu and sigma were different, like, than the original? Like, is that just like a standard version or something?
Oh, yes, making me proud that baby, yes.
And then
Um,
that's just our
And you didn't
sample.
even look in your tablet.
I know, right?
Yeah. So it is a standardized version. This process is called standardization.
Oh, okay.
So if you took the value 6.50, subtracted the mean 6.50, the numerator would become 0. Do you agree? So 0. If the numerator has the standard deviation of 0.5, you divide by 0.5, then you will get 1. If you want more information on this, pick an undergraduate start textbook. Do we still have it? You can Google it or YouTube. Do you still have my notes, baby, or did you burn it?
Oh my gosh, I had a notebook and then I got my iPad and I don't know where my notes are.
Okay, great.
And also you told us not to buy the textbook, so I don't have the textbook either.
I never said that.
Yeah, you did. You were like, don't buy the textbook, and then you were like,
Don't buy a hard copy, use the ebook.
no,
Good
you
news for
said,
everyone,
you
you
said
can
we-
find the textbook at LibGen.
that what?
You can find the textbook for free on LibGen.
Yeah, you can.
I did.
But I remember because this kid next to me was like, I just bought it, and I was like, yikes, I didn't.
Google empirical rule of normal distributions, and you will see as to why when we make the standardization, you get a mean of 0, standard deviation of 1. Good. Standard means free of any assumptions whatsoever. No assumption made about the mean, no assumption made about the standard deviation. By assumption, I mean a value that could affect your conclusion. So 0, 1, standard. Here is a question. If I collect data going back to last time, and I'll show it again today, the one in light blue, the histogram that we remember from last time. That light blue histogram is from data. And that had means I varied the average. I moved it back and forth to illustrate alpha and beta last time. Could I take that histogram and compare directly to this? Paul says no. Do we agree with Paul? You agree with Paul? You switch from governor to
I'll
governor.
always stay with Donner, but I'll agree with Paul this time.
Okay, you can't directly compare the data to this. You have to convert the data to z-scores as well. Then you can make the comparison. By another distribution. Going back to Jonathan, it is not historical data that tells us to do all of this and come up with that standard distribution, standard normal distribution to size. It's rather nerds like me who derive and prove that this is the distribution to use for a given scenario. Good. Yes. So theory of